Hello everyone. Today we are going to talk about linear regression explained in 10 minutes. After watching this video, you will be able to master the basic concepts and programming skills of linear regression analysis. What is linear regression? Linear regression is a statistical method that helps you understand the relationship between two variables. For example, here there are some data points scattered on the graph, and you want to find the pattern and draw a line that best fits these points. In a nutshell, this is linear regression. This line is called a regression line and can help you predict values and see future trends in your data. The equation of this line is simple: y equals to wx plus b, where y is the predicted value, w is the slope of the line, x is the input variable, and b is the y-intercept. As shown in the figure, by adjusting the values of w and b, the fitted line will move accordingly. So how does linear regression find the best fit line? We define a loss function that quantifies the difference between the actual value of the target and the predict value. The most commonly used loss function in regression problems is the mean squared error, MSE. The smaller the value, the better, which means that the line fits better. The squared error function MSE can be defined as the formula in the figure. Subtract the actual value of y from the predicted value, then square it, then add up the squares of the errors of n points, and finally divide it by the total number of samples n to get an average of the squares of the differences. To find the best fit line, we need to find w and b so that the value of the loss function MSE is minimized. To find its minimum value, we need to calculate the derivative of the loss function with respect to w and b, or the gradient. We use the gradient descent method to minimize the loss function. This method can optimize almost all deep learning models. It reduces the error by continuously updating the parameters in the direction of decreasing loss function. This iterative process continues until the algorithm converges to the best possible straight line. By minimizing these differences, linear regression provides us with a line that best represents the trend of the data. Here, j is the loss function, where we find the derivative of j with respect to w and the derivative of j with respect to b. There are some derivation and simplifications. The detailed steps are here. If you are interested, you can pause here and take a closer look. The formula in the gray area will be mentioned again in the code implementation part. In this iterative process, the setting of the learning rate data is very important. The following three pictures show three scenarios of learning rate setting. In the left picture A, the learning rate is too small and it takes a long time to reach the optimal value. In the right picture C, the learning rate is too large and it's easy to jump back and forth and miss the optimal value. Only in the middle picture B, setting a suitable learning rate can achieve the desired goal in the shortest possible time. Now let's summarize the linear regression method based on gradient descent. First, set the initial values of the parameters w, b, and the learning rate LR. Now start training, which is carried out in an iterative loop. and the loop will not stop until convergence. In each iteration, the linear equation formula is needed to calculate the predicted value of y, then compare the predicted value with the actual y value to get the difference. Finally, the gradient value is calculated according to the gradient formula to update the parameter values w and b. With this basic understanding, we can start programming. Even if you do not fully absorb the previous content, you still can continue watching, and after seeing the implementation code, you will have a deeper understanding of some of the previous mentioned content. So let's get started. First, we want to import some libraries. We use the NumPy library, and this is used for the data processing. We also want to use the matplot library, and this is used for visualization. The second step is to generate the data. And we want to generate the data randomly. Here the x has the dimension of 101, which means it consists of 101 dimensional values arranged in a column. And the y value equals to 3 times of x plus 11, and we also want to add some noise. For convenience, we want to merge the w and the b, so you see that the equation, we made a little change here. This equation becomes like this, so we will add one column at the end of x. Now we need to initialize the parameters w, that's some random values between 0 and 1, and we will have the w and b, so it's two-dimensional. The learning rate would be a value between 0 and 1, and we pick 0.1. The iteration number, we pick 1000. Okay, we will start the iterative process. If you still remember the slides, that we have a gray region with this equation to calculate gradients. Then we will need the gradients and the learning rate to update the w value. Okay, so we finished the training part, the training loop. And now we want to test some x value, so we will create a new value of x. We want to use our updated w, the trained w value, to predict the new y. Okay, this is our test. So in the end, we want to visualize the whole process and see what is really happening. So we want to plot all the x and the y values, and these are our generated data. We also want to plot the value of x new and y predict. You see that we pick the x new value to be 0 and 1, so it helps us to find the slope and the intercept of this line. Okay, in the end, we also want to print the slope and the intercept value, because we know the real w and b value, so we want to make a comparison in the end. Okay, so we have this, the blue points are the training data, and the red line predicted this line pretty well. And you see that the slope value is 3 and the intercept value is 11, which is very close with our real parameters. So that's it. That's all for today's sharing. If you like my video, please don't forget to like, subscribe, and comment to let me know what you want to see in the future. This is Zebra Coco theory. See you next time.